Before we start talking about polygon angles, we'll first go over some basic angle facts. So if there are two lines that intersect each other, then the angles that are opposite each other are congruent, and they're called vertical angles. If there are two parallel lines, and there's a line that goes through both of them, then these angles are corresponding angles, and they're congruent. If there are two parallel lines with a transversal, then these two angles, which are the alternate interior angles, are also congruent. And combining alternate interior angles with vertical angles, we can also see that in two parallel lines, these two angles on the outside are congruent, and they're called alternate exterior angles. So let's draw a triangle between these two parallel lines. So from alternate interior angles, we can see that this angle is equal to that, and this one is equal to this angle. So the sum of these three over here is 180 degrees because it forms a straight line. And so the sum of the angles of a triangle is also 180 degrees. Let's look at this polygon, which is a hexagon, so we can label its points as A, B, C, D, E, and F, and extend the sides past the points in the same rotational direction. And we'll label these angles on the outside, oh, I missed one, with red. And these are called the exterior angles. And these on the inside are interior angles of the polygon. So if we draw these extensions centered at the same point, like this, then we can see that after labeling these angles as exterior A, exterior B, and so on to exterior F, we can see that these angles correspond to the ones between these extensions. So from this diagram, we can see that the sum of all of the exterior angles is just 360 degrees. So let's say now we want to find the sum of the interior angles. So the sum of the interior angles plus the sum of the exterior angles is also the sum of these 180 degrees for each of these vertices. So if we say there are n sides, then this is equal to 180 times n degrees. So the sum of the interior angles is then equal to 180 n degrees minus the sum of the exterior angles, which we found above is 360 degrees. So this can be rewritten as 180 n minus 360 degrees, or 180 times n minus 2 degrees. So another way we can see this is if we choose some point and draw segments from the point to the vertices in this polygon. We can see that we've created n triangles, or in this case 6 triangles. And the sum of the interior angles would then be the sum of these 180 degrees for each of the n triangles, but we have to subtract this center circle, or 360 degrees. So this still gives 180 n minus 360 degrees, which is 180 times n minus 2 degrees. We'll finish with 2 example problems. So let's say we have a regular octagon A, B, C, D, E, F, G, H, and midpoints of B, C, D, E, F, G, and H, A at M1, M2, M3, and M4. and we want to find the measure of angle AOM2. O is the center. So we can draw the diagonals through O, AE, and BF, and draw the segment M4, M2, which also passes through O. And then we can also draw the rest of the diagonals, HD and CG. So we can see that any of these angles is 360 divided by 8, which is 45 degrees. So this is 45 degrees, and this is 45 degrees. So we want to find DOM2. Notice that this angle is right, and these two angles are the same because triangle OED is isosceles. Also, they share OM2. So these two triangles, OEM2 and ODM2, are congruent. And that means that these two are each 45 divided by 2 degrees. So measure of AOM2 is 45 degrees 3 times plus 45 over 2 degrees, which is 315 over 2 degrees. Now let's say we have a regular pentagon and we want to find this angle. So we can see that these lengths are the same by symmetry, and these two lines are parallel. So these two shaded triangles are similar by ASA similarity, and these angles are congruent. So the sum of the interior angles of this pentagon, like before, is 180 times 5 minus 2, which is 540 degrees. And this is regular, so that means that each of these angles is 540 divided by 5, or 108 degrees. So this is isosceles, and that means that these two base angles are each 180 minus 108 divided by 2, which is 36 degrees. And so this is 36 degrees, and this is 36 degrees. So if we let this angle be y, and these are all y, then from this vertex we get 36 plus y plus 36 is 108. So y is equal to 36 degrees. And now we can look at this triangle at the bottom. And we can see that this angle, this red angle, is 180 minus x degrees and 180 minus 2y. So x is 2y, which is 72 degrees.